Imagine standing in a laboratory, not just watching data on a screen, but actually witnessing reality unfold in real time. That might sound like science fiction, but it's already happening in the world of quantum physics. Scientists are now working with machines so precise they can observe the smallest elements of reality, quantum particles, as they move, shift, and even change course in real time. For years, physicists have been mystified by the observer effect, the strange idea that simply watching a particle can change how it behaves. This wasn't just a wild theory. Repeated experiments proved it. Particles act one way when unobserved and another way when someone's watching. It was like the universe was aware of being watched. But now, something incredible has changed. Scientists using Google's advanced quantum processor have managed to observe particles without disturbing them. This is no small feat. Traditional observation techniques used to collapse the wave function, the mathematical description of the particle state. That meant the act of observing destroyed the very thing being studied. To avoid this, researchers used a superconducting quantum chip, chilled to nearly absolute zero. In this frozen state, even the tiniest disturbance would ruin the data. But this chip was different. It was built specifically to work within this sensitive environment, making it one of the most advanced tools in physics today. Using quantum entanglement, a phenomenon where particles are deeply connected no matter how far apart, scientists developed a method to observe particles in motion without breaking their state. They didn't just watch the particle. They predicted its future while watching it move. And here's where it gets mind-blowing. The act of observation no longer breaks the system. It actually becomes part of the system. The observer and the particle enter a kind of quantum dialogue, a feedback loop where each influences the other. The boundary between what is seen and the one seeing is no longer clear. Instead of crushing the quantum state, scientists are now able to guide it gently, like steering a canoe through a river without causing ripples. This transforms the observer effect from a frustrating limitation into a powerful scientific tool. It's no longer about what we can't do, it's about what we can finally control. This breakthrough reaches back to 1927, when Werner Heisenberg introduced the uncertainty principle, which says we can't know both a particle's position and speed at the same time. That idea still stands. But now, scientists can predict the path of a particle with incredible accuracy, even while observing it live. It's a massive leap from where we were. We're going from still photographs to real-time interaction, from watching silently to participating in the very evolution of the quantum world. The chip Google developed took 5 years to design and build. It was created not just to detect particles, but to communicate with them, forming what's called a coevolutionary loop. In this loop, measurement and evolution happen together. It's not just about taking data, it's about shaping outcomes as they happen. Scientists are beginning to think that observation and evolution in quantum systems might be two sides of the same coin. Imagine future quantum computers that could fix their own errors as they run, identifying problems in real time and adjusting on the fly. That's no longer wishful thinking. It's a real, repeatable process. This changes the game for quantum computing. Systems that once needed massive corrections could become self-healing, which is essential for building error-free quantum computers. These new machines would offer unimaginable power for processing data, running simulations, and even unlocking new laws of nature. And it's not just computers that benefit. The technology could touch every part of life: medicine, climate prediction, cybersecurity, and even the study of consciousness. But it doesn't stop there. In one experiment, scientists noticed something completely unexpected. When particles were watched continuously, they started to act like they knew they were being watched. This strange behavior led to what researchers now call self-referential coherence. The longer the particles were observed, the more stable they became. At first, researchers thought it was a bug. But repeated experiments confirmed it was real. According to Dr. Rao of MIT, this might be a new physical law, one that only shows up under constant observation. At Caltech, Dr. Eric Lindstrom had a different take. It's like the quantum system is adapting to our presence. Could we be seeing new layers of physics that were hidden until now? It's not just poetic. It's a new way of thinking about reality. Some scientists now suggest these coherence effects may point toward hidden dimensions or undiscovered variables. Reality might be layered like an onion, and right now, we're just scratching the surface. With better techniques, we could soon start to explore these deeper layers. Think about it like this: you shine a flashlight into a cave and realize there are tunnels you never knew were there. That's what modern physics is doing, lighting up parts of the universe we never imagined. Of course, Not everyone is convinced. Some skeptics argue that these strange behaviors might be quirks of the chip, not new physics. But the research team didn't stop there. They tried the same experiments using different quantum systems, like trapped ions and photonic platforms, and saw even stronger results. That tells us this isn't just a hardware trick. It's something much deeper and more universal. A big reason for this success is the integration of deep learning AI into quantum experiments. Google trained a neural network on huge quantum datasets. During the experiment, the AI received live feedback and updated itself in real time. It didn't just improve its predictions, it rewrote its own rules. Some scientists now call this ability quantum intuition. Dr. Alina Zhou of Stanford said, "We watched an AI co-evolve with the quantum system. That's more than prediction, it's partnership." This AI didn't just react. It learned, adapted, and innovated, spotting patterns that humans would never catch. It became a true collaborator, not just a tool, but a thinking, changing partner in scientific discovery. Just imagine where this leads. An AI that discovers new medicines by testing molecules that don't even exist yet. A system that models Earth's climate as it happens, adjusting predictions hour by hour. This is the start of something transformational. But with this power come serious questions. If AI can learn, grow, and control quantum systems better than we can, what is our role? According to experts, we become guides and curators. We provide the vision. The AI provides the ability. It's a shared journey. We decide what questions to ask. The AI helps us find answers faster than ever. But we have to ensure that these powerful systems follow ethical rules. Dr. Ellen Harper, a leading AI ethicist, warns, "We're building minds we don't fully understand. We have to set clear rules about what they're allowed to do and who controls them." Despite these concerns, the potential is breathtaking. These systems could allow small labs to compete with tech giants, making science more democratic. They could help solve global challenges like carbon capture, dark matter, or even mental health research. This is more than just a new computer. It's a new scientific age, one where we're no longer bystanders. We're shaping the outcome with each observation, each calculation, and each collaboration with AI. Google's quantum core hasn't just solved an old mystery. It has redefined what it means to observe. We are now active participants in the unfolding story of quantum evolution. The observer is no longer an outsider. We're inside the system, helping to create its path. As we explore this new world, we're uncovering more than particles. We're discovering new ways of thinking, being, and learning. And this is only the beginning. As quantum machines grow and AI continues to evolve, we may uncover new laws of physics, new types of technology, and new philosophies of how we relate to the universe. What once seemed like limits are now opportunities for exploration. The frontier isn't far away, it's right here, in how we choose to see, measure, and interact with reality itself. Subscribe to our channel and thanks for watching.